Big changes are in store for safety engineering because of the advent of autonomy and in particular autonomous vehicles. Conventional software safety engineering works by doing hazard and risk analysis, for example, according to the ISO 26262 Functional Safety Automotive Standard, and by mitigating the hazards to achieve acceptable risk. In general, there's a convenient fiction employed here, which is assuming that you have perfect safety when you're deployed. Now we know it's not entirely perfect, but the idea is if you think you're almost perfect, or as far as you know you're perfect when you deploy, you can go at the safety engineering a certain way. One of the things that comes along with that is realizing that the scope of safety is significantly limited if you have a human operator present, because you can delegate a lot of the control of hazards to the human operator. If there's something that's a loose end in safety that you didn't get quite right, a human operator is there to save the day. So you're depending not only on getting the safety engineering right, but also on delegating all the messy loose ends, the unknowns, all those things you're not quite sure what to do about. You've got a human operator there, and the human operator takes care of it. What happens if the human operator isn't a human anymore? What if it's a robot? Now, this is a fun picture of a humanoid robot that actually did drive a vehicle for a short distance, but what we expect is the ability to drive the car goes into the car itself, giving us an autonomous vehicle with no need for a human driver. Safety for autonomous systems isn't about a notion that when you ship the vehicle, you're done, that's it, for the life cycle, it's safe. That's not going to work for autonomous vehicles. You're going to have to look at change over the life cycle. Partly that's because machine learning-based validation is immature. We're just not to the point where you can build a machine learning system and be absolutely certain it will be safe for its lifetime with life-critical responsibility. We're just not there yet. But even if we were there, you'd have an additional problem that the environment itself is imperfectly understood. You don't know everything you're supposed to teach the machine learning system so that it can be notionally perfect at it. There's unknown unknowns, there's gaps in requirements, and so on. Even if you were able to get the system perfect on the day you deploy it, even in a messy open world, that world's going to change the second you deploy, the next day, the next year. Things will change that your system isn't ready for, and so you're going to have to evolve to keep up with the changing world. When it comes down to it, you're going to have to, for safety, join security and end up doing constant system monitoring and constant system updates for both safety and security. Given security issues, it was already going to be that way for conventional systems. But once you add autonomous functionality, especially things like machine learning, there's just no way around it. We're going to have to keep evolving and adapting these systems over the system lifecycle. So the question is, how do you do that?